surface areas of solids are the combined areas of all the faces of the object. You've probably seen these before. Some people refer to this kind of diagram here as a net of a solid. And it's really just all the faces laid out, and you could arrange it any way you want. For surface area of the object, you just need to find the area of each of those parts and add them together. I'm going to do the triangular prism as an example, but it's the same idea. Prisms are always composed of several rectangles that go around the object, combined with two bases that can be any polygon. This is a rectangular prism because the two bases are rectangles. And this is a square prism, a cube, or you could call it a rectangular prism because squares are rectangles. And this is a triangular prism because it has two triangles opposite from each other surrounded by rectangles. So let's find the area. Each of the triangles is 9 by 8, so you would do 9 times 8 divided by 2. 72 divided by 2 is 36. So they're each 36. Now the interesting thing about triangular prisms is when you add those two areas back together, you get 72 again. So we sort of divide by 2 and then multiply by 2. And that's just an interesting coincidence with those prisms. For the rectangles, we've got 5 times 8 is 40, 5 times 10 is 50, and 5 times 9 is 45. So you just add all those together, and we get 207 square centimeters all together. So that's prisms. Let's look at cylinders. For a cylinder, it's made of two circular bases, and this region in the middle, that is really just a big rectangle. If you imagine slicing this label made of paper and opening it up, you would see that that turns into a rectangle. The dimensions of the rectangle are the height of the cylinder, right here, and also the circumference of the circular base. If you imagine that it has to wrap around the circle, you can see why that would be true. I've written the circumference as 2r pi. That's obviously the same as diameter pi, so you can think of it either way. When the radius is given, I use the radius. Okay, let's put some numbers in here. So let's say that for this one, the radius is 3 and the height is 5. And let's see what happens. We've got pi times 3 squared, which equals 9 pi. So the area of each circle is 9 pi. And those are done. I'm going to do the whole problem in terms of pi. So now we've got the rectangle. The height is 5, and we don't know the base yet, so let's figure that out. Okay, we've got 2 times the radius times pi. So this is 6 pi. 6 pi times 5 is 30 pi altogether. So that's the area of the rectangle. And all that's left to do is combine those three things. And obviously you can think of this as multiplying 9 pi by 2. So we've got 18 pi plus 30 pi is 48 pi altogether. And the units are not marked, so you need to label it as square units because it's area. And that's what you do with a cylinder. If you want a decimal approximation, you need to plug in a decimal approximation for pi and then round to the desired number of decimal places. Here's a square pyramid. Pyramids are named based on the base. Whatever polygon you see in the base, that's the name of that pyramid. It could be octagonal, it could be hexagonal, it could be rhombic. Sometimes they're not even regular polygons and they stand crooked, but we're not going to do any of those. So for this one, notice we have two different heights marked. The interior height is the height that goes straight down the center as perpendicular to the base. That's the height of the pyramid and would be used for volume. We're going to use this height instead. That's called the slant height. The slant height of the pyramid needs to be used for surface area. Let's look at the net. So we've got a square base that's 14 on every side, and it's surrounded by isosceles triangles. And they are identical despite what my artwork looks like. So each one has a height, wow, that's crooked, that is the slant height 25, and the base is 14, just like all the sides of the square. So we have 4 of them, so we're going to find the area of one of those and multiply it by 4. So we've got 4 times, and then the area formula for triangles is 1/2 times base times height. Okay? Now for simplifying purposes, you could either do 1/2 of 14 right now by cross-reducing, or since this is all multiplication, the parentheses really aren't doing anything different than the multiplication symbol is, and you could reduce the 2 and the 4 as well. So I'm just going to go ahead and do this since I've got an even number in here and start multiplying everything that's left. So I've got 7 times 25, which is 175 times 4 more. And that is 700 altogether. So that covers all the triangles. To that, we need to add our 14 squared for the area of the square. And for those of you that are memorizing your perfect squares, you know that's 196. So all together, if we add those two together, we get 896 square units. So for pyramids, the only thing that would change if the base was a different polygon would be you need to use the appropriate formula to find the area of the base, and then the number of sides, the faces that go around it, these triangles, will vary depending on how many sides the base has. So if you had an octagon in the bottom, you'd have 8 triangles. And that's how pyramids work. Okay, let's look at a cone. A cone is made of a circular base and a sector of a circle that wraps up into a cone-shaped shell. So that's kind of interesting because we don't already have a formula for that. I'm giving you a new formula today, right here. Notice that it uses slant height. Now in a cone, the slant height is part of a right triangle. If I filled this in and put radius on both sides, notice that this is a right triangle. So if you're given the slant height, then you can plug it right into the formula. If you're given the height of the cone instead, you could simply use Pythagorean theorem to find the slant height, right? So the slant height is equal to the square root of the height squared plus the radius squared, if you need that. Okay, let's try an example. So for this example, I have the slant height, so that's my S, and I have the radius, so that's my R. Let's just plug them in. So we've got pi times the radius squared plus pi times the radius times the slant height. So this is 25 pi, and this is 65 pi, and those are easy to simplify. That's 90 pi, and that's your total surface area in meters squared or square meters. And once again, that is an exact answer. If you need a decimal approximation, you plug in a decimal for pi and round to the appropriate number of digits. And that is surface area in a nutshell.